say that we were given a function f of x equals x squared, and we wanted to find the derivative of this function, meaning that on a graph of x squared, and let me draw my best rendition. On a graph of x squared, we would see a parabola, and we want to find a function that would give us the difference quotient between two extremely close values of the graph of f of x equals x squared. So basically, if we take the slope on an extremely small interval, let's say the difference between the 2 points are going to be a difference of 0.00001, right? If we were to take the slope at that point, it will in effect give us the instantaneous rate of change. So we could draw a tangent line going off in this direction, and that would give us the value of the derivative at that point. So we want to find a function that will give us the value of the derivative at any point. Well, using our power rule, we know that f prime of x would be equal to 2x. So we know the derivative would be 2x, but how do we arrive at this conclusion? I mean, we want to be able to prove this. So we use the definition of the derivative, which we know to be the limit as h approaches 0 of f of x equals f of x plus h minus f of x all over h. And basically all this is like I've said before, calculating the slope on an extremely small interval between 2 points, where h, like you can see over here, h is going to be approaching 0. And we do this in order to make the difference between these 2 points so small that a tangent line at this point is going to give us the derivative of this function. So we input, in order to solve this, we input the limit as h goes to 0 of f of x is going to be x plus h squared minus f of x all over h. And we can just rewrite that as, we can do out x plus h times x plus h is the same thing as x plus h squared, which would give us x squared plus hx plus hx plus h squared. And keep in mind that we still have the f of x here, which just represents another x squared. So we could tack on another minus x squared here, all over h. Well, the minus x squared, the x squared and the minus x squared would just cancel out, and we would be left with 2hx plus h squared all over h. Now remember that h is approaching 0. So in effect, h is going to get so close to 0 that we can even cancel it out. So we could write something like the limit as h approaches 0 of f of x equals 2hx plus h squared all over h. And then we could kind of draw something like this to symbolize that h is going to 0. And what are we left with? We are left with f prime of x equals 2x. And this is how we calculate and prove the derivative of a function. You know, it's not enough to just say, oh, okay, let's do the n-1 rule, the power rule, and we'll know the derivative. No, we have to be able to prove these things. So this is how you prove a function, any function. I mean, you can do this with any power function. You could even do this with exponential functions, which I'll be doing in later videos.